I have a triangle right here. I started out with this triangle right here. I'm going to rotate it. Are those two triangles still congruent? Why? Why are they still congruent? What would you write as a little explanation to tell me, after I've rotated it, why those two triangles are still congruent? 14. Nice job. Say that one more time, Nate. That was pretty impressive for the first time around. It's rotations are rigid motions, which do what? Keep distance and angle measure. Everyone like that response? Because that's what we're going to be doing today is you did a transformation, which hopefully is a rigid motion. Why are the two figures congruent? So we're going to go and do proofs with transformations, except it's not going to be in a statements reasons column. All right, that's our goal today is do proofs with rigid motions, except they're not in a statements reason, but it is in a certain way I want you to write it. And Nate did a pretty darn good job right there, all right, for the first time how I want it written. So take a look at the first example you have under using rigid motions. I reflected triangle A prime, B prime, C prime is the image of triangle ABC after reflection. Why are the two triangles congruent? It's basically what Nate just said here. Reflections are what? It's a type of rigid motion, yes. So reflections are rigid motions. And what do we know about rigid motions? They preserve what doesn't change in a rigid motion. They preserve distance or side length and angle measure. I'm going to require a lot more here when the problems change, but for now, just get in the idea of, hey, transformation, whatever you have, reflection, rotation, translation is a rigid motion. Rigid motions preserve distance and angle measure. That's why the two triangles are congruent. They do not change their size or shape because distance and angle measures are preserved. All right, let's get a little bit more complicated. You tell me what the rigid motion is now. Number one, I told you it was a reflection. Now you tell me what the rigid motion is. And get specific. Reflection isn't going to cut it anymore. A reflection over what? Rotation isn't going to cut it anymore. A rotation around what? How many degrees? So I'm going from ABC and XYZ. Use properties of rigid motions to tell me why they're congruent. So what you need to do in your group right now is come up with a way to get these two on top of each other using reflections, translations, rotations. And I would appreciate it in this example if you only use one. Don't use a sequence of them. Just use one rigid motion and get specific. Don't just tell me the word. Tell me where you're reflecting, where you're rotating, where you're translating. About a couple minutes here. Go ahead, talk to your group. How are you going to get triangle ABC on top of XYZ? Okay? Get specific too. Get specific. Okay, which groups have it? What did I do to get ABC on top of XYZ? Which groups have it? Okay, I'm done. Here we go, group with 18 in it. That's exactly what I need. One more time, Matt. There you go. It's a rotation. Not good enough. Not good enough anymore. A rotation of 180 degrees around the origin. Yes, sorry, I didn't give you enough room to write that in. Around the origin. All right, since, what transformation did I just do? Since rotations are what? Rigid motions. You guys are figuring out the template here. Rotations are rigid motions. They preserve distance and angle measure. Ooh, how about this one coming up? Thus. Yep, that's what I need. I needed to prove the triangles are congruent. Thus, triangle ABC congruent to XYZ. If you would like, because obviously I'm not going to have blanks for you to fill in, and neither is the Regents exam. So if you'd like your own word other than thus, feel free. Anybody else want to substitute in a word? Thus, therefore. What do you have? So. In conclusion, I like that. I might need a spelling for that one. Henceforth. Okay, so whatever low. You're going out of my league now. If that works, I'll take it. All right, if we want to add in some Shakespeare. Anybody else want to throw something in there? Because I said so, right? Because I said so. ABC, that's always good when you're desperate. It's got to be true. You wouldn't have asked me. Whew, all right. That was one transformation. Now find me multiple transformations that get ABC on top of A prime, B prime, C prime. It is asking for, take a look in the directions after a sequence of transformations. That means two or more. In this case, can you and your group find two transformations that would plop ABC right on A prime, B prime, C prime? Okay, and I know I kind of give it away through the blanks, but remember you're going to have to try this one on your own soon without the blanks. So tell me what I can do to ABC to get to A prime, B prime, C prime in two moves. In two moves. ABC to A prime, B prime, C prime, two moves. I think I made it too easy on this one because I did give the blanks. Might want to update your labels there, huh? Still trying to live through the good old days. Math 8x. Okay, what's it undergo? Hey, a little help. Up here we go again. Matt, let's go. You know the deal. 6. What's this undergo? A reflection through the y-axis. Yep, notice how we're getting detailed. Reflection won't cut it anymore. Through the y-axis. And then what else do I need to do to it there, Stacy? Yep. And a translation of, what did you say? Okay, 3 units up. Well, here you go. Ready? You reflected A through the y-axis. Where's it got to go to get to A prime? Down. So you could say translation of 3 units down. You could put it in vector notation. You could put it in function notation. Okay, it doesn't matter. Anything happen to the x coordinate? Nope. So I'm just going to write. I'm going to write it in vector. Again, guys, you can write it out in words, vector, function notation, whatever you prefer. But are we all focused here where you have to not only say reflection, but we're reflecting through now? All right. And then finish it off here for me since. Oh, go ahead, Stacey. Sure. Yep. Okay. Never mind. Need a number. Why do I keep going back? Go ahead, Stacey. Need a number. 8. Hold on. Yep. Yep. Equals. All right. Ooh, no blanks here. Sorry, everybody. No blanks. Let's focus on part A first before we get to part B, which is explaining why they're congruent. We're going to do triangle double primes, A double prime, B double prime, C double prime. How do I get to that triangle? It's the image of ABC after a translation 5 units to the right and 2 units up. From there, it's a reflection over the line y equals 0. Oh, boy. Hold on. Y equals 0. Another name for... Hey, y equals, it's got to be what type of line? Horizontal. And if it's horizontal through 0, it's got to be, another name for it would be the x-axis. All right? So that's what I need you to do in your group first, is find out where triangle A double prime, B double prime, C double prime will be. I'll ask you for the coordinates, and then we'll write our own proof from scratch, no blanks. All right, so go ahead and translate it, then reflect it over the line y equals 0. Good idea. Good catch. Can I get those coordinates here? Can I get the coordinates? Ethan, need a number. 14, can I get these coordinates? Those are correct. Make sure you check them. Any issues? All right, why are the two triangles congruent now? What's a great little paragraph I could write here that says these final triangles are, the original and the prime, double prime triangles are congruent. Nate, let's go. No, need a number. That's how this goes. Okay. No, thanks. What would you, why are they, you just tell me in your own sad words. I may be asking, that's poison right there, but go ahead. So why?
Because ABC underwent a translation.
Okay, that's fine. I know it already worded that because you don't have to write that if it's already told to do it. You only would write it if you needed to find out if you actually did that. Okay, so translations and reflections. What do you know about them? Yep.
Both reflections and translations
Are rigid motions. Which which preserve distance and angle measure. Use thus. Okay. Double what? Begins with a P, ends in rhyme. Oh, God. Oof. Questions? Would you have a problem if I tried number 1 out with you? All right, because I get a little nervous with number 1 on the homework because it's not on a graph anymore. So how do I get specific as far as reflection, rotation, translation if I'm not on a graph? All right, so I'm going to do homework problem number 1 with you, and then you guys can go on your own. Okay. Write a sequence of transformations. So I'm looking for 2 transformations here that would map ABC onto DEF. All right. Can you guys just tell me the transformations, and then I'll help you guys with the specifics about degree measure, translating, line to reflect over, etc. What 2 transformations could I do here that would match those 2 triangles up? And I know I've already kind of gave it away, but Saad? I could do a rotation first and then slide it on top. Everyone agree? Okay, so we're going to go rotation, translation here. Rotate, translate. And I've already started to help you out with the fill in the blanks. How do you want to rotate triangle ABC? Because remember, A's got to match up with D, B to E, C to F. How would you want to rotate it? In which direction? In which direction would you like to rotate it? So it's an easy translation to slide it over. Rotate it. Clockwise, everyone in agree? I'm going to go that way, clockwise. All right. All right. Where do you want to, where's this point I'm going to rotate it around? Well, there's really no other point here, but you can rotate it around one of the vertices. So which there's not a wrong answer here. Which vertice do we want to rotate it around? Sure, we can rotate it around A, B, or C. There's no wrong answer for this part anyway. So about point B. And again, you could write in A or C. The other thing you could do, because this was a Regents problem last year, the other thing they could have accepted is, I don't know if you guys remember last week, but I showed you how to find the point of rotation, where you connect an image and a pre-image point, do the perpendicular bisector, and then do it again for another set, and where the perpendicular bisectors intersect, that's your point of rotation. You could do it that way and name that point yourself. All right, if I rotate it around point B, then I would slide it along which vector now? If I turn this around point B, where's B got to match up with? 2? E. So what I wanted to slide it along which vector? Vector B, E. If you pick point B, your vector's got to be BE. If you picked vector point A, your vector's got to be AD. So it all depended on what point you ended up rotating around. If you did the construction and found the point of rotation, you could do any vector you wanted to. All right, you could go from B to E, A to D, or C to F. All right, but it all depended on what point you rotated around. And what do you know about rotations and translations? They're both rigid motions that preserve distance and angle measure, thus triangle ABC congruent to DEF. So sometimes it won't be on a graph. This was a Regents problem last year. Here's where kids got credit off. Anybody want to guess where they got credit off? That's all they said. Rotate and translate it. You got to get specific. That's why I'm trying to harp on that. I don't want to see that again this year. All right, you got to get specific on where you're rotating and translating. If you're not on a graph, you got to rotate around a random point and a vector to translate it. You guys are on your own for the next two. You guys might want to help each other out with that next one because it's not the easiest one to figure out how to map them up. Okay, so you may want to help each other out, move around, work with other people if you don't want to work with people in your group. Evan? Well, you can't make a random point. That random point has to be where the perpendicular bisectors intersect. What's that? Then you get your choice. You can move it you can go A to D, B to E, or C to F. Yeah, any one of those three vectors would have worked. Okay?